For track events longer than 100 meters, more than half the race is run along the curve. And curve running velocity can be described as a function of the runner's mass m, curve radius r, and centripetal force production Fc. Now, individuals that need to use a running specific prosthesis, this can be challenging because prostheses are designed for linear running. However, Filar Composites has designed a running specific prosthesis where the distal end is split in the anterior-posterior direction. This is going to theoretically increase traction and centripetal force production along the curve, so we tested its sprint performance compared to a traditional solid prosthesis of similar shape, material, stiffness, and mass. We compared these two prostheses across two curve conditions, one that represents lane 1 of a 200-meter track and one that represents lane 1 of a 400-meter outdoor track. We hypothesized that the split prosthesis will result in increased sprinting velocities as well as centripetal force production compared to the solid prosthesis. Here are the speed results for the 3 participants in our pilot study. On the x-axis is the solid and split prosthesis, on the y-axis is sprinting velocity, and the colors denote the different curve conditions. Overall, there was a 0.13 meters per second increase in sprinting velocity in the split prosthesis compared to the solid prosthesis. However, there was not a significant difference between centripetal force production between the two running specific prostheses, despite 2 of the 3 participants having increased force production in the split prosthesis. Overall, the 0.13 meters per second increase would result in about a half a second saved over the course of a 400-meter Paralympic race, which could be the difference between a bronze and a gold medal in the Paralympics. Overall, our pilot study suggests that more research needs to be done to confirm the speed effect, identify underlying mechanisms, and potentially test new prosthesis designs that could improve sprint performance in individuals with a running-specific prosthesis.